guys, so in this video we will be going through problem 3 from the module 2 not packet. In this question, the runner averaged a speed of 5.4 meters per second for the first 10 meters of a 100 meters race. Then she averaged a speed of 9.4 meters per second for the final 9 meters of the race. So we are asked to calculate the time taken to complete the race and her average velocity for the race. Okay, so first we should understand that average velocity of an object does not tell us anything about what happens to the object in between the starting point and ending point. For example, we cannot tell from average velocity whether the runner was slowing down or speeding up while she was in motion. For that reason, I'm not going to draw a motion diagram. So let's start by defining a coordinate system. I'm going to have right as positive. We will assume that Jenna ran in a straight line. Okay, now let's identify knowns and unknowns. This motion consists of two segments. For the first part of the motion, initial position is 0 meters. Final position is 10 meters and displacement is final position minus initial position. So displacement is 10 meters. And also average velocity is 5.4 meters per second as it is given in the question. I'm going to use the subscript 1 to denote displacement and average velocity for the segment 1. And also this bar indicates that it is an average. Okay. So for the second part of the motion, initial position is 10 meters and final position is 100 meters. So the displacement is 90 meters, 100 minus 10. And the average velocity for the second segment is 9.4 meters per second as it is given in the question. Now I'm going to put a question mark for the unknowns. Delta t, time elapsed, total time taken to complete the motion. And the second unknown is the average velocity for the race. So now I'm going to include them in symbols in here. Okay. So first, we need to calculate the delta t, the time taken to complete the race, and then the unit of time is seconds, and then the sign of time. Okay, let's talk about it a little bit. So time is a scalar quantity and elapsed time is the total time taken to complete the race, and it's always increasing. Therefore, I expect a positive sign for the elapsed time. And also the next variable is the average velocity, and the unit of average velocity is meters per second. And okay, let's talk about the sign. The average velocity of a particle moving in one dimension can be positive or negative depending on the displacement. Jenna is moving to the right. Jenna has a positive displacement. So she's moving to the right. She has a positive displacement. For that reason, I expect a positive number for average velocity. Okay. And the coordinate system, yes, we have specified the coordinate system. We have right as positive and applicable concepts. So Jenna is moving in a straight line. So this is a 1D kinematics problem. And this is chapter 2.3 in your textbook. Okay. Now let's plan a solution. So this equation is in your module 2 note packet, and also it's in the equation sheet. So the average velocity is defined as the total displacement divided by the elapsed time. In addition, when the acceleration is a constant, average velocity can be found by taking an average of the instantaneous velocities at the beginning and end of the time interval. But that's only when the acceleration is a constant. Okay. Okay. Now let's use average velocity equation for the first segment of the motion, and then let's cross multiply the average velocity and time interval for this segment, and then we get the equation for the time interval or the elapsed time for the first segment of the motion. That is equal to displacement divided by the average velocity, the first segment. And again, we have the average velocity equation for the second segment of the motion, and we can cross multiply the velocity and time to get the equation for the time interval for the second segment of the motion. Now, if you want to calculate the elapsed time or the total time taken to complete the race, you have to add the two time intervals delta t1 and delta t2. Very simple. And once you add the displacement for each segment, you get the total displacement. And when you have the total time interval and total displacement, you can use this equation to calculate the Jenner's average velocity for the race. Okay. Now, then let's once you have the plan, it is really easy to execute it. So let's substitute knowns and solve for the unknowns. Okay. So the time interval 1 is displacement for the first segment divided by the average velocity for the first segment, 10 meters divided by 5.4 meters per second. You get 1.85 seconds. And let's confirm the units. So see on the numerator, you can see on the numerator you have meters, and on the denominator you have meters per second, and this meters is going to cancel out with meters, and then you have 1 divided by 1 over seconds, and reciprocal of 1 over seconds is seconds. Okay, so the reciprocal of 1 over seconds is seconds. You get seconds for the unit. And then let's look at the time interval for the second segment. Displacement for the second segment 90 meters divided by the average velocity 9.4 meters per second. Again, look at the units. Meters is going to cancel out with meters, and then reciprocal of 1 over seconds is seconds. You will end up of getting 9.57 seconds for the second time interval. Then let's add the two time intervals to get the total elapsed time. Once you do that, you have 1.85 seconds plus 9.57 seconds is equal to 11.4 seconds. Then the total displacement, so the total displacement is the displacement for the first segment plus the displacement for the second segment, you get 100 meters, or else you can simply take 100 meters minus 0 for the displacement, for the total displacement. Okay, and then the average velocity is total displacement over elapsed time, and now you have the total displacement, which is equal to 100 meters, and then divide that by 11.4 seconds, and you get 8.77 meters per second for the average velocity. Okay, and now you can see the units. You have meters on the numerator and then seconds on the denominator, so your unit for the average velocity is meters per second. Okay, now let's check and evaluate. Okay, so it is important to note that we cannot calculate average velocity of the entire trip by taking the average rate of 2 segments. That means average velocity is not just 7.4 meters. Okay, so it was not 7.4 meters per second, because you cannot simply take the average rate of the 2 segments. Just keep that in your mind, and now let's see, is the solution complete? Yes, it is complete. We calculated the time elapsed and the average velocity for the race. And is the sign of the answer correct? Yes, as expected, we got positive values for the delta t and the average velocity, and this answer have correct units. Yes, we got seconds for the time, and then for the velocity we got meters per second. And is the magnitude of the answer reasonable? So 8.77 meters per second is fast, but possible for elite runner. So yes, it is reasonable.